Great. So let's get started. There'll be probably a couple of people joining a bit later on, but we may as well get into the main purpose of today's session. So thank you for being able to attend. The main topic for today's webinar is going to be accelerating innovation with machine learning on Amazon Web Services. In terms of the high level agenda that we're going to be covering today, it's going to be first starting with an introduction to who I am as well as my business. We're going to then start with a why, and obviously given the fact that we're living in an interesting time at the moment, and as we're being faced with a new normal, I think it's quite critical that we understand, why is innovation and why is machine learning critical given the current climate. I'm going to then go through what is machine learning before speaking about some of the opportunities and challenges. I'm going to then cover some common use cases and why cloud and specifically Amazon Web Services is, a great place to look at doing machine learning, before discussing some of the lessons that we've learned in delivering over 100 machine learning projects, but also what we've been hearing from the market, before finishing up with a question and answer. So just a bit of housekeeping for today's session. Could I just make sure that everyone's on mute? The reason being is that this session will be recorded and uploaded. The easiest way to facilitate your questions at the end of this session will be to type those questions in the chat as we go throughout today's session, and then I'll make sure I cover them at the end of today. So a bit about myself. My name's Cal Temple. I'm the co-founder and co-CEO of Intellify. I'm an honorary affiliate at the University of Sydney, and I've been working in analytics and machine learning consulting for over 5 years. In that time, I've delivered over 50 different machine learning projects. And my background is a Masters of Economics in Economics and Econometrics. And my master's thesis was in a specific area related to machine learning, specifically interpretable machine learning. And also I'm the co-founder and also organizer of PyData Sydney, which is a community around data analytics and machine learning in Sydney. As a brief introduction to my business, essentially we are a data analytics and machine learning consultancy. We've been around for 2.5 years. We're about 25 people, and we've delivered projects in 5 cities across Australia, as well as delivered some work in New Zealand, Switzerland, and the US. Essentially, we help our customers in 3 different ways. One is to essentially help them understand the value that is created by data and machine learning. And this is around helping them to define a roadmap and strategy to unlock as much value as possible from these technologies. The second one is around consulting and execution, where we help organizations to design and implement data and machine learning solutions. And the last one is essentially where customers would like a capability, but they don't necessarily want to come along and build it in-house and also run that service in-house. We have the capability to work with our partners to come along and build an internal capability and then run that capability for you. We were awarded the AWS Partner of the Year for Data Analytics and Machine Learning in 2019. We're also one of 2 machine learning competency partners in Amazon Web Services. And that's due to the fact that we've been able to deliver a large amount of machine learning outcomes for customers in different industries, but also in different business functions. So we've done everything from customer churn prediction through to pricing optimization, through to time series forecasting and computer vision. Typically the type of organization that we'll work with in Australia is quite a large enterprise, typically above $1 billion, and they'll typically be the FSI or industrial in nature. So moving on from the introduction to the why, I want to first start with why businesses being forced to innovate. And I see that there's 3 critical areas as to why businesses are being forced to innovate, given the current new normal that we're faced with. And the first one is around a shift in cost and operating model. And this is the fact that organizations now want to start thinking about how can they go from fixed costs to variable costs. And this is because with the current crisis that we're faced with, businesses that have flexibility and agility in their business model are better able to cope with the situation where there's essentially a demand and a supply shock in the current moment. The other thing there is around the operating model, and this is because businesses have been typically, operated face-to-face, but they've also been typically brick and mortar based. And this meant that all of their sales and also all of their operating model has essentially been around delivering in-person experiences. What we've obviously seen over the last couple of months is the fact that that in-person experience has completely changed to a online-only digital experience. And this has meant that resources, budgets, but also capabilities need to be reshifted inside organizations away from these face-to-face interactions to digital capabilities to be able to make sure that organizations are able to give the outcomes that their customers are expecting. The second most important reason as to why businesses are being forced to innovate is to try and drive sales stickiness. And this is the fact that most companies are producing homogenous goods. And in the current climate, this means that businesses and customers are really looking to get as much value from their partners as possible. And this means to start thinking about driving sales stickiness, businesses need to focus on loyalty, and this means that they need to differentiate themselves. One of the ways that businesses can look at differentiating themselves is through using things like machine learning to improve their customer experience. And by having a better customer experience, either through contact call centers or through websites or through the applications that consumers are using, this means that they're more likely to continue to use their business. But I think the most critical one is the fact that businesses have had to undergo an accelerated digital transformation over the last couple of months. And this, digital transformation is something that people previously wouldn't have thought has been possible. But it's been facilitated through the fact that people have had to start working from home. They've actually had, or businesses have had a shift in the preferred sales channel. But also the fact is that all these legacy systems that businesses have been roped into over the last couple of decades, they've essentially realized that these legacy systems have not been able to provide the flexibility that they need to be able to thrive in a time like this. And what this means going forward is that I believe that there's a new precedence that is being set by this crisis, where businesses will essentially strive for all these three pillars. They'll essentially fundamentally think about how they structure their business. They'll fundamentally think about how they service customers and they drive brand loyalty. But also the fact is that this accelerated digital transformation will go beyond the current crisis that we're faced with. It will essentially be persistent for the next couple of years, which means that businesses need to be thinking about how to become digital first. So moving on from the why and taking a bit of a different pace to what is machine learning, I wanted to first level set everyone in terms of what is predictive, prescriptive, and descriptive analytics. And the reason why I think that this is quite critical is the fact that when we start speaking about machine learning, artificial intelligence, data science, there's typically a lot of misconceptions of what these things are in the market. So taking a step back, if we start speaking about what are these three different types of analytics and how do they align to data science and machine learning, the first type of analytics is descriptive analytics. And this is essentially the analytics and business intelligence tools that most businesses have been familiar with and have been using for the last 5 to 10 years. And this is the process of using your historical data to be able to understand what has happened and surfacing that to people such that they can use that information to make judgments about the future. And the main critical thing about this descriptive analytics is it's about surfacing that historical data and making sure that people are using that data to be able to make decisions. How predictive and prescriptive analytics are fundamentally different is rather than using a subjective human-based way of making decisions, is that they're essentially trying to use these complex mathematical algorithms to try and understand general patterns inside the data such that you can make objective data-driven decisions. And this is not necessarily around taking the power out of people making decisions, but it's the fact that when you start speaking about understanding complex patterns in large amounts of data, that machines and machine learning models are essentially a lot more effective at trying to discern the true signal from the noise in these types of problems. So when we start speaking about what is predictive analytics, this is about building a mathematical model on top of historical data that allows you to tell what will happen. And this could be the fact that you want to be able to predict what customers will churn, what is the amount of sales in the next 2 weeks, or essentially when is a machine going to fail. And this process of creating a model, an algorithm that essentially tells you what will happen is known as predictive analytics. When you start speaking about prescriptive analytics, this is about a machine learning system telling you what will happen, or rather, what should you do given what will happen. And this is typically when you start hearing the words optimization, this is what is referred to as prescriptive analytics. So when you start thinking about inventory optimization, price optimization, workforce optimization, all of these types of use cases, outcomes are essentially prescriptive analytics solutions where some form of artificial intelligence solution will come along and say the optimal amount of goods to stock on any given week based on the current sales that we're expecting over the next couple of weeks will be 50. And essentially what it means is that you're given now a data-driven objective recommendation on the decisions that you should make, such that a person can take that with a grain of salt and obviously apply their additional wisdom on top of that. But there's a bit of confusion in the market, and sometimes people believe that when we talk about machine learning, that it's just the typical analytics and business intelligence. But when you talk about machine learning, realistically, what it is this predictive and prescriptive analytics. The other thing is that a lot of people get confused about what the difference is between data science, machine learning, and artificial intelligence. And I've tried to clarify in this diagram essentially how do those three terms, how are those three terms separated. And when you start speaking about what is data science is the end-to-end process of taking a business problem, formulating it in such a way that it can be understood by a statistics or machine learning algorithm, applying those algorithms on top of that data set, and then essentially thinking about how it can be integrated into a business process. The main middle piece of that process, the data science process, is essentially machine learning. And when people refer to machine learning, they actually refer to three different things: statistical learning, machine learning, and mathematical optimization. But people just tend to group it into the term of machine learning. And hence, when we start speaking about, what is machine learning, it's essentially that fundamental component in the middle of a data science process, which essentially solves what you're trying to do. But when you speak about the outcome of a data science process and machine learning algorithms, that is typically what's known as artificial intelligence. And over the next couple of slides, I'm going to attempt to further refine and clarify these definitions. So if we go a bit lower and start speaking about, can you give me a clear and concise description of what is data science? It's essentially the use of a scientific research method to turn a business problem into a statistics and machine learning problem. This problem will be then solved through the use of both domain expertise as well as statistics and machine learning. And when I talk about domain expertise, I'm really talking about either some form of business expertise, engineering expertise, or just a really strong fundamental understanding of the problem that you're trying to tackle. Once you actually have a good understanding of the domain and also the types of algorithms that would be the best fit for the problem, the next thing is about trying to deploy the solution in the real world. And this is going to be through some form of combination of data engineering and software engineering. And then finally, just because you've got a production solution doesn't necessarily mean it's creating value for the business. So it's around taking that solution and then trying to think about how can these outcomes of the solution be communicated and integrated back into the business. And this is through some form of data visualization. So integrating a machine learning prediction or predictions into some form of business intelligence or data visualization application, or it could be around trying to integrate these predictions into some form of application. So for example, an ERP or an inventory management system, etc. So moving on from what is machine learning to, from what is data science to what is machine learning, it's essentially the process of teaching a computer to learn without being explicitly programmed. And you'll find that there's three different types of machine learning. There's supervised, unsupervised, and reinforcement learning. And I'll try and quickly just give you some examples of the different types of machine learning. But the main thing here is that when you start speaking about applicability to business, the main machine learning type that you'll be seeing across enterprises is going to be in the supervised machine learning space. So let's start there. So what supervised machine learning is essentially you have some data, which is the inputs, and you have an outcome, which is which is essentially the output that was produced by those data inputs. And what you're trying to do is you're trying to build a machine learning algorithm that can replicate the relationship between those inputs and outputs. And this means that you have to have historical data on what was the inputs that we used to produce that outcome, as well as the outcome. And a great example of this is when you start thinking about bank loans. So a good example of how that would actually work is around looking at data when someone submits a bank application. So that would be in terms of the income, information about themselves. It could be where they live. It could be around the types of finances, etc., that they currently have, and that is then being used historically in the past to set a credit limit or a credit threshold. And what this machine learning system will do is essentially look through the historical input data and the output data, that being the loan application information and the final credit loan, the credit limit or the credit loan that was assigned to that person, and it'll essentially figure out the rules and the relationships between those inputs and outputs. When you start speaking about unsupervised learning, this is typically when we don't actually have an outcome that was observed, and we want to be able to understand how can we predict something that hasn't necessarily happened before. A really good example of this is around anomaly detection and predictive maintenance. And this could be the fact that you've got a whole bunch of data which represents what the normal state of that machine looks like, but you don't actually have many labels that predict when that machine, many labels that show when that machine failed. And what that means is that you have to come along and build a machine learning algorithm that can understand what has happened well, and essentially that will use that as a proxy as to when things are going to be working well. And anytime things start deviating outside that pattern is when things start getting flagged as either being a risk or some form of anomaly. The last type of machine learning is reinforcement learning, and this is where there's essentially very few business applications that have been put into production at the moment, and probably the best applications of reinforcement learning have been done in the realm of games. So there's a really good documentary which I would recommend watching called AlphaGo, and it's essentially the process of how a team called DeepMind ended up building a machine learning algorithm, specifically a reinforcement learning system, to beat the world's hardest board game, Go. And how that works is essentially there's an environment which typically dictates the conditions that machine learning algorithm or system is trying to operate in. So for example, if you start speaking about optimizing a data center, it could be the fact that there's a certain number of servers in the data center, there's a certain number of servers that can be turned on or off at any given time. And there's a certain amount of price that you'll have to pay for energy at any time of the day. And what will happen is that this agent will essentially look at that environment. It'll have a reward, which is typically around, in the data center context, minimizing energy costs or energy usage. And what it will do is it will essentially perform forward-looking simulations multiple times by taking an action in that environment, seeing what was the effect and how it actually increased that reward function to then come along and optimize its actions. And as I said, it works really well in the scenario of games. The reason being is that games have really well-defined rules. However, there's been few applications in the real world at the moment of using reinforcement learning to achieve really impactful outcomes. So when you start going from that, what is machine learning, to what is artificial intelligence? Artificial intelligence is the ability for a machine to exhibit human-like cognition, and is typically the output of one or more machine learning algorithms. And when you start speaking about artificial intelligence, there's essentially two different types. There's general artificial intelligence and narrow artificial intelligence. When people think about general artificial intelligence, this is essentially the all-knowing, all-seeing robot who's going to come along and take over the world. And the answer is that the research and the ability for us to produce algorithms that come even close to doing this is nowhere near happening. This is at least 10 to 15 years away. And what that means is that when people start speaking about narrow artificial intelligence, when they start speaking about artificial intelligence, they mean narrow artificial intelligence. And this is essentially where you can use a machine learning algorithm or multiple machine learning algorithms to replicate the process that a person was doing previously. So for example, in Amazon.com, you might have 2,000 people who are coming along and doing SKU ordering, that being product ordering. And Amazon.com doesn't actually use people to order and to do all of its inventory management and planning. It uses machine learning algorithms. And when we talk about narrow artificial intelligence, it's that exact example where we're essentially using machine learning to supersede tasks that could be done better through machine learning, rather than getting people to do this manually and inaccurately. So moving on from, what are these different terminologies, how do they play together, and essentially how do they work? I want to then start speaking about what are the opportunities, because having a cool technology that's, helps organizations doesn't really mean anything if you can't actually create value through it. So the first opportunity through leveraging machine learning is around increasing growth and market share. And what I would say is that all organizations want to increase growth and market share, but not all strategies to do this are created equal. And what machine learning allows you to do is to better understand your business, your customers, and your market, which allows you to think about acquiring your customers more effectively, increasing their customer lifetime value, and obviously maximizing their customer retention. And that sounds very easy, but when you start going from those outcomes, the increase or the acquiring customers more effectively through to increasing customer lifetime value and then maximizing customer retention, what we talk about when we talk about those use cases is things like pricing optimization, marketing mix modeling, recommendations, and customer churn. And there's case study after case study after case study about how organizations are able to achieve, large revenue or profitability gains through leveraging machine learning in these areas of their organization. The second opportunity is around reducing costs and increasing efficiencies. And the main thing here is around using machine learning to identify inefficiencies in business processes. So when I talk about this area, I see there being two primary parts, and this is around labor and this is around non-labor assets. So when you start speaking about labor, what we've found in a lot of labor intensive industries like retail, warehousing, logistics, and service providers is that they have a really core challenge, and this is around finding the right number of people with the right skills at the right cost. And this comes down to capacity planning and workforce optimization. And one of the biggest benefits that we've actually seen is the fact that businesses can use machine learning to forecast a full roster that is needed to essentially effectively deliver their solution, so that they're not over rostering or under rostering. And what this means is that they're able to increase the productivity of their business. And at a time like this, it's obviously critical for businesses to start thinking about maximizing productivity. So the second part of this is around increasing non-labor assets capacity or availability. And this is through increasing the asset uptime. And this is around using machine learning for things like predictive maintenance on production plants, vehicles, LNG wells, etc., to be able to make sure that those assets are being available when needed and they're not being shut down unnecessarily. Because what we typically see is that when you start having an LNG well go offline for a substantial period of time, or for example, another oil asset going offline for a substantial period of time, we're talking about costs in terms of tens of thousands, if not hundreds of thousands or millions of dollars, depending on how long that asset becoming unavailable lasts for. And this means that there's huge opportunities that can be realized by making sure that you're using machine learning to increase the uptime of your assets. The third one is around increasing accuracy. And I ended up working with a startup at the University of Sydney where they were trying to detect glaucoma using machine learning in retinal disc scans in people's eyes. And what they ended up finding is that if you went to a GP, there was essentially a 50-50 chance as to whether that GP could come along and diagnose you correctly as to whether you had glaucoma or not. If you went to a specialist, it might be about 70 to 75%. And if you went to a specialist, it was about 90 to 95%. They ended up taking 4,000 images, medical images of the back of these people's eyes that had labels of whether they had glaucoma or not. And what they ended up finding is, just based off these 4,000 images alone and essentially training a deep learning algorithm, was that they were able to achieve an accuracy of 92%. And what this means is the fact that you can take an algorithm like this, you can put it in a device and you can put it in the hands of a GP or a specialist. And it's obviously able to massively improve the quality of care or the outcomes that are being able to be delivered for these patients. So when people start speaking about improved accuracy, it's not necessarily about taking away people's jobs, but it's about trying to provide them with additional assistance that will help them do their job more effectively. So the next one is around helping businesses be more fast and scalable. And this is around allowing your business to scale to your compute power rather than to your human resources. And what we've found is that a lot of businesses can realize substantial growth benefits by thinking about removing labor-caused bottlenecks inside their business. And what we've found is that for clients whose core business is labor intensive, that if they think about using machine learning, it's typically around augmenting or automating tasks of their business, parts of their business that don't scale. And the outcome that we've typically seen from this is the fact that they're able to win new contracts, better serve their customers, but also better position themselves for global scale. And a good example of this is the fact that we worked with a leading geosurveillance business and we were able to automate 85% of their LiDAR radar classification process. And the core challenge for them is the fact that it ended up taking them, a week or so for them to come along and process this LiDAR radar data. And this meant when they started speaking about serving customers at scale, they were essentially fundamentally limited by the amount of people that they were employed, which is obviously a bit of a challenge for them, given the fact that there's high technical skills that are needed for this LiDAR radar classification process. So by coming along and helping them build this machine learning system, what we end up finding is the fact that we could do this in hours rather than weeks. And this then allowed them to start thinking about, serving their customers on a more frequent basis, but also accepting more contracts, allowing their business to start thinking about this global scale. But I think one of the biggest advantages of machine learning is thinking about how can you leverage it to achieve competitive advantage. And when you look at businesses like Uber, Airbnb, Facebook, Netflix, and Amazon.com, what really stands out for me when I think about these businesses is their ability to innovate, but also create algorithms that disrupted their industries, but made them, differentiated, unique leaders in their field. And this is because those who undertake these initiatives as early adopters start realizing how hard it is to do data science and machine learning effectively. But at the same time, they learn a lot of the very valuable lessons which bleed over from data science and machine learning to general digital capability, but also to just general technical capability across the organization. And what you can obviously see from these organizations is the fact that they, were essentially created in a very short period of time, and they've essentially been able to come along and be the market leaders in their field. And when you start speaking about, large enterprise businesses across Australia, New Zealand, and, the rest of the world, one of the core challenges for them over the coming years is how can they start thinking about, clearly driving differentiation and competitive advantage through the data assets that they possess inside their organization, but also by creating value-added services through things like machine learning. And this is obviously going to then cement their place as the market leader in their respective field. So moving on from the opportunities, because all of those sound great, through to some of the challenges, what are some of the challenges that I've seen in the field in terms of organizations coming along and applying data science and machine learning effectively to come along and solve enterprise business problems? And the first one is that, organizations that want to come along and do this effectively essentially need to find and hire unicorns. And, the first challenge is around finding. The second thing is around hiring, because every business likes to think that they're sexy, but unfortunately what we see in the market is that a lot of data scientists are the ones who get to choose where they want to work. And because of that, even if an organization can, pay a lot of money for a data scientist, they may not necessarily, want to work there. But I think one of the challenges that when I started doing this webinar series over 2 years ago that we ended up seeing at the time was that there was the rise of the LinkedIn data scientist. And I'm not sure if anyone's familiar with that term, but it was essentially around business analysts, DBAs, business intelligence people essentially rebranding themselves as data scientists. But what I would say is that they're actually not the biggest challenge in the market at the moment. What I would actually say is the fact that there are too many data scientists in the market, and unfortunately those data scientists are typically overly academic. And you'll find that there's a lot of people who've moved from academia to industry, or there's a lot of people taking courses at the moment and trying to move into industry. But the biggest challenge is that these people don't have the right mix of skills to succeed in the workforce. And that's because they've spent too much time working on algorithm development and model development on toy problems in non-enterprise environments. And what that has meant is that they're quite ineffective when you start speaking about identifying the right use case, going to a data source, pulling from source, building those data transformations that need to be done, and then essentially building algorithms and deploying algorithms, and then essentially engaging the business to make sure that it was something that they wanted, but also then leading the change management. It's obviously quite a complex process to go end to end, but it's the fact that a lot of the data scientists can only do about 10 to 15% of that process. But a lot of organizations believe that those people should have the end-to-end capability to do that whole process. The other challenge that we've seen in the market is the fact that a lot of organizations who are looking to leverage consulting partners to be able to deliver these types of outcomes don't know how to properly vet these companies in terms of their data science capability. And this comes to the fact that, organizations looking to do data science and machine learning haven't done it before, and hence they don't know necessarily what to look for in terms of a consulting partner. The second challenge is around requiring strong digital and data foundations. And this is really quite critical to being successful in machine learning. And this, when we start speaking about digital and data foundations, it's composed of a couple of different components. The first one is around having a workbench where a data scientist can come along and readily access the tools and data that they need to be able to come along and build the algorithms. So it could be the fact that there's a environment, an IDE, that whatever it is, where a data scientist can come along, they can use R, they can use Python, they can use the machine learning libraries that they want to use, but also at the same time, they've got access to the data that's being stored in Amazon S3 or Redshift or any other form of data store that they have. And the biggest challenge here is that workbench essentially doesn't exist. And that means that these data scientists have to come along and build custom tools, or essentially have to go along and figure out that tooling puzzle before they can even get started. The second issue is around having a platform that provides high quality, well-structured and governed data. And when I say that, a lot of people just say, well, that's not possible. And what I would say is that it's impossible to do it all in one go, but I've actually seen a lot of organizations do it quite well when it's around specific use cases or use case driven. And when you actually have that platform that has specific parts of the business where it's got a well-defined business use case in terms of the value that you can get from that data, it is well-structured, it is governed, and it is high quality. This is a massive accelerator of being able to deliver data science and machine learning effectively. But I think one of the most critical things is around having a platform that accelerates the amount of experiments that you can run. Because what I've found is that essentially speed beats perfection when you start speaking about machine learning, because there's so many lessons that need to be learned. And this means that if you have a platform that can help you accelerate that experimentation, it means that the faster you can learn those lessons to the point in which you can then start learning what effective data science and machine learning at an enterprise scale looks like. So moving on onto the third use case, a lot of organizations have been hiring data scientists, and unfortunately they haven't been able to see the return on investment. The reason being is that they haven't been able to identify use cases that drive tangible benefits. And this is because they don't know where to start with machine learning. They don't know either how to get buy-in from the business to start having conversations around their pain points, problems, and essentially the vision and strategy they need to deliver. The second one is identifying the right use cases that are going to deliver benefits to the organization upfront, but at the same time are not overly complex. They can be clearly time boxed, and they're essentially going to support getting executive buy-in. The challenge then is also about, once you've got those use cases, about understanding how to prioritize them and turn them into a roadmap. And what you'll find that sometimes that you'll have too many ideas, but not a proper framework to come along and prioritize these, which then means that people are just paralyzed with too many choices rather than committing to an individual use case to come along and build it out and to see how it works. The other thing is around, a lot of people might be able to put a model into production, but the biggest challenge is about trying to come along and quantify the benefits of that model. And I've seen few organizations do a really good job of essentially looking back on a model over the last 6 months, 12 months, and coming along and saying, this is the value that is being created by this model, and essentially being able to go to senior executives and then get further support and buy-in for other machine learning initiatives, because they've been able to clearly identify the value created from previous initiatives. So when we start speaking about the last challenge that I've typically seen in delivering data science and machine learning effectively, it's around the fact that there's a new way of working that is required to be able to do this effectively. And this is around organizations moving from siloed functions who don't work well to cross-functional agile teams, which are composed of both many technical roles, but also business roles. And this is around having a product owner from the business. This is around having a data engineer, a solution architect, a data scientist, potentially a business analyst, also potentially, a data visualization expert, all working in that same team for a common goal. Because only when you start combining these teams in an agile manner for a discrete project, or rather a product, where all those technical skill sets are brought together, do you really start seeing success across the organization. But also you need to start thinking about, how do we actually have people like analytics translators across the organization? Because there's just a lack of data literacy across organizations, which means the fact that when you start speaking about how you can help them with their data and machine learning initiatives, they just don't understand what type of outcome they're going to be getting. And hence, having people who can engage the business and speak to the value that it creates is critical in terms of getting buy-in from them and also support with them, because ultimately the data science and machine learning functions exist to serve the business. So moving on from the opportunities and challenges to, where is machine learning being, used across organizations? Primarily it's across two functions. And this is a study by McKinsey Global Institute around where analytics and AI, which is around where I'm calling machine learning and artificial intelligence, creating value for organizations. And what you can see here is that in marketing and sales and supply chain management and manufacturing, the vast majority of value is being created in these two functions. And that, for me, essentially is very clearly aligned to the fact as to whether an organization has a growth mindset or a cost mindset. And when we start speaking about a growth mindset, it's essentially around how can we acquire and engage and retain customers as much as possible. And hence there's a huge amount of value that can be, acquired at scale in terms of those initiatives. But then when you start speaking about the cost-minded organizations, this is around they've got large market share and they don't have competitors that are challenging them substantially. So it's around how can they essentially reduce their fixed and variable costs as much as possible to essentially generate as much profit as possible. And this is around how can we start thinking about improving the efficiency and efficiency of our supply chain. That being said, there's obviously still a large amount of value that can be found in other areas around operations, risk, product development, strategy and corporate finance, etc. But it's just that the fact that we typically see the most value being created around this marketing and sales function and supply chain and manufacturing function. So when we start going from those two high-level functions to, what does that actually mean in terms of use cases? I've just given you an example of 6 different use cases that would be reflective of what we talk about when it's the marketing and sales use cases. And this is things like pricing optimization. So for example, we've delivered pricing optimization 5 different times for our customers. Propensity model, which is around, increasing the likelihood of cross-sell, upsell, or just better identifying what types of products and services that customers want, and that encompasses things like recommendation engines. There's obviously then personalization, and when you start speaking about personalization, this could be in terms of your marketing, in terms of how you show content on your website, but it could be also just in terms of how you interact with your customers through marketing and other channels. You've then got examples of things like marketing mix modeling, which is essentially that you've got 5, 6, 7 different sales channels, and you've got a fixed budget, and you want to figure out what is the optimal way to spend that budget across those marketing channels. It's around essentially determining elasticity of each of these channels to determine sales and how you can optimize it. And there's things like customer segmentation and sales forecasting. So moving on from marketing and sales to supply chain and manufacturing, there's a lot of very different use cases in here. And when we start speaking about supply chain and manufacturing, it's typically around those optimization use cases that I spoke about before. So things like inventory optimization, workforce optimization, yield optimization, route optimization. And this is essentially around how can we make sure that we're as effective as possible in delivering outcomes for customers, or essentially in the process of producing outcomes for customers. The only other thing that I'd probably call out is around the predictive maintenance and defect detection. So when you start speaking about predictive maintenance, this is around making sure that assets are staying available and up. And obviously by having an asset available, that means that the revenue that asset can generate is obviously being increased. But when you start speaking about defect detection, for example, if you're manufacturing, cardboard boxes or other goods and services, depending on what type of defect rates you're talking about, this can add up to a substantial cost to the business. And hence, if you start thinking about using machine learning, either in terms of taking IoT data or computer vision and essentially assessing goods in close to real time, this can essentially speed up that defect detection process and obviously improve the customer experience. Rather than sending out faulty goods, you proactively identify it. So I want to quickly go through some use cases that we've delivered for customers to be able to speak to the types of outcomes that we've been able to deliver in market, but also to give you some inspiration about how are customers using machine learning in Australia and New Zealand. The first one is with Alinta Energy, and they wanted to forecast what was the energy consumption of their business customers in Victoria. And what we ended up doing was essentially engaging their business experts, but also their business intelligence experts to understand, what are they trying to achieve and what are the complexities of that particular problem, as well as what data do we have to work with. We ended up engaging them for about a 6-week project. And in that time, the outcome was we ended up getting a triple-digit increase in the accuracy at an individual customer level of these demand forecasting models. And what that means is that they're going to obviously be able to then capacity plan more effectively. This can feed into their trading models, but also anything else inside their business that uses these demand forecasting models can now essentially benefit from that more accurate prediction process. The second one was in terms of Vodafone. So we ended up building a recommendation engine for Vodafone around identifying what were the right plans and phones to be recommending to consumers to be able to help them upgrade digitally. And the reason being is that obviously, you know, most telco businesses, getting a customer to upgrade online is going to be the smoothest process. It helps customers self-service, but also it's the most profitable. And hence, we end up building some machine learning models that allowed customers either through their email campaigns or Vodafone.com to be able to come along and essentially receive a personalized recommendation as to the right phone and plan for them. The next one was with a company called C-Link, and this was around building them a dynamic pricing framework that allowed them to increase profitability on some of the cruises. And the core challenge for them, and obviously the tourism industry has been hit very hard given the current climate, it's about understanding what dictates customers' willingness to pay. And what you'll find is that pricing can be used to influence profitability, but at the same time, it's also essentially a lever that can be used to control demand. So for example, when you start speaking about a cruise ship, there's obviously only a certain amount of capacity that a cruise ship can hold. And obviously the closer to capacity that you get, typically the better benefit there is for that company. And it was around building a dynamic pricing framework that helped C-Link understand how did customers make a purchasing decision, what was their willingness to pay, such that their profitability could be increased. And the value that we identified was essentially a double-digit increase in their revenues for operating that particular sub-brand of their business, which obviously is, you know, a substantial business impact. So moving on from the use cases and case studies to Wise Cloud, you know, we're an Amazon Web Services partner, and you could come to me and say, Kale, you know, why are you doing so much work in cloud rather than on-prem? Some people still have concerns about data security, et cetera, in terms of why they work on-prem. But I think the answer is that when you start speaking about delivering machine learning, there's a really compelling reason as to why it should be done on cloud. The first is around the scalability and cost efficiency. And for those of you who don't know, machine learning workloads are extremely bursty. Essentially, you have two different phases inside them. The first is what you would call exploratory data analysis, which is typically pulling data from the source, doing some form of data transformations, doing some data visualization and other like high-level tasks. This is essentially long duration but low compute. However, when you start speaking about training a machine learning algorithm, this is typically when you speak about short duration, but extremely, extremely high compute. And this means that if you're talking about trying to do this on-prem and you've got a dedicated server for doing machine learning, most of the time that really expensive server is going to be sitting idle. And it could be the fact that this had, you know, 100 cores, a couple of GPUs, you know, half a terabyte of RAM. And we've actually seen workloads where we've had to use these type of specs to deliver them effectively and to make sure that model training times were not too long. And obviously what you can do in the cloud is essentially you can very easily access these servers with these types of capabilities in a couple of minutes, spin them up, set up your machine learning training job, launch it into either a server or a cluster, train your machine learning model, and then essentially come along and kill that server or that cluster. And what that means is when you talk about saving money and the cost effectiveness, but also being able to facilitate effective data science productivity through essentially reducing training time through having compute scalability, the cloud essentially massively benefits their productivity, but also the cost effectiveness of trying to deliver these solutions effectively. The second point is around flexibility. And what you'll find if you've done much work with data scientists is that everyone's got a flavor of of either Python or R that they like to work with. And it could be that they've got some individual libraries that they like to work with, or it could be the fact that they've got some tools, whether that be Databricks, NIAM, SAS, whatever it is, right? And what we've found with the cloud is it's extremely easy to come along and provision and access different data science and machine learning tools, either in terms of native AWS services or in terms of third-party services that can run on the cloud. And what this means is that if a data scientist wants to come along and experiment with different tool sets, with different frameworks, with different languages, they can essentially do this in minutes, rather than having to worry about setting everything up, configuring it, making sure that it runs, because out of the box, cloud, but also these third-party services essentially can facilitate that. The other thing is that we've seen a very effective use in containers in data science and machine learning in terms of making data science and machine learning work more reproducible and about moving this work through multiple environments. So for example, if a data scientist come along and built a model that works in your dev environment and they want to roll it from dev to test to prod, essentially containerizing that model and then essentially allowing it to roll through those multiple environments essentially saves you a huge amount of time and effort when you start speaking about productionizing machine learning solutions. And obviously containerization fits into the model of cloud extremely well, and hence kind of why it's an effective combination of those two technologies. The third one is around ease and accessibility, and this is the fact that a lot of organizations have silos, specifically data silos that exist inside the organization. And what we've found is that as organizations have moved to the cloud, they've essentially thought about how can they start consolidating these data sources either into an enterprise data lake or into an elastic data warehouse. And what this means is that when a data scientist or a data engineer or anyone else inside the organization wants to come along and build a use case, whether that's for BI reporting or for data science work, it has meant that they're more easily able to come along and consume data, aggregate data, integrate data, and interrogate data to effectively deliver those use cases in less time. And hence, it's an accelerator. So when we start speaking about moving from the cloud to specifically Amazon Web Services, Intellify had a choice 2.5 years ago to determine which cloud service provider that they wanted to work with at the time. And what we ended up identifying at the time was the fact that Amazon Web Services had the broadest and most complete set of machine learning capabilities. At that time, they were releasing Amazon SageMaker, which is essentially their state-of-the-art machine learning platform. And what we see in the marketplace today is the fact that Amazon Web Services has a huge array of what we call AI services, which are essentially pre-built, pre-trained machine learning and artificial intelligence models that allow a developer, a technology consumer, to come along and leverage these state-of-the-art solutions that are being built by Amazon Web Services. So for example, if you start speaking about Amazon Forecast or Amazon Personalize, these are essentially a demand forecasting, time series forecasting framework and a recommendation engine framework. And what this means is that you get to leverage the state-of-the-art capabilities from Amazon.com with less engineering and overhead to come along and build your own custom solution. And hence we've actually found that, going forward in the next 2, 3, 4, 5 years, we believe that AI services are going to be everywhere and they're going to be something that a lot of businesses are looking to consume. The second one is that when you want to come along and build custom machine learning models, which is obviously quite common for us, this Amazon SageMaker is the platform to do that. And it's essentially a platform that gives you the ability to label your data, leverage custom-tuned algorithms from Amazon Web Services that speed up training times. They give you hosted Jupyter notebooks, which means that your data scientists can come along and readily access a cloud environment based on Jupyter Notebook, which is a common tool that they're used to working with. But it's also got things like automated machine learning and also model hosting and model experimentation features as well. And then obviously when you start speaking about businesses going back to basics and trying to build stuff on top of infrastructure, obviously if customers are looking to do that on top of either containers or servers, AWS has a huge amount of capability in terms of supporting TensorFlow models, PyTorch models, MXNet models, and other frameworks to essentially run on top of these different compute services that they do have. So if we start moving on from the why cloud and why AWS onto what are some of our lessons learned and what are some of the lessons learned that we've heard others talk about in market, I can speak to what we've seen in the market in delivering over 100 different machine learning and data science projects. And there's some pretty common reasons as to why these projects succeed and why they don't. And the first one is the fact that you should always start with a business problem and work your way back to technology. We've seen too many people come along and say, I want to do machine learning. And we say, well, what do you want to do machine learning on? And essentially they haven't thought about the type of use case or business benefits that would be realized through the technology. They've just thought it was essentially a technology they can come along and leverage. And what this means is that if they don't have that right mindset about starting to think about solving a business problem from day one, we ultimately know that that project is most likely going to fail, or it's going to struggle to get executive support, or it's essentially going to be not anywhere near as successful as it could have been. The second one is the fact that time spent on the business case and validation of the business case and assumptions will pay huge dividends later on. And this has been the case that when we've typically engaged, senior stakeholders, they'll have some assumptions about what's wrong in the business. But when you start diving down into the roots of the organization in terms of the boots on the ground, people who are actually doing the work, what you'll find is that a lot of those assumptions were different is probably the nicest way of putting it. And what that means is that you need to be able to fundamentally understand what you're trying to solve, because if there's wrong assumptions that you're using when you come along and build a machine learning model, essentially it's not going to work. And hence, that upfront validation of these use cases is critical. The third one is about having an executive sponsor. The reason being is that it's critical to get visibility across the organization if the project goes successfully, as to start thinking about that second, third, fourth project, but also how do you come along and productionize these machine learning solutions? Because building an algorithm in a proof of concept environment is not necessarily so hard, but when you start speaking about productionizing it, you obviously need quite a large business case to come along and support that, which means that you need an executive typically to come along, be there for the journey, serve as your advocate, make sure that's aligned to corporate strategy, but then also help assisting in getting buy-in from other stakeholders when you want to come along and productionize that machine learning model or system. The fourth one is around making sure that you don't try and boil the ocean. We've seen organizations, want to come along and build a huge enterprise data lake based on 15 sources that are all, strictly governed and have high quality data in it before they start speaking about building out a machine learning use case. And what we would say is that irrespective of whether it's for business intelligence or for machine learning, you should ideally be working from the business problem back to the technology, which means that ideally you break your projects off into small bite-sized pieces. That means that if you do run into any platform or data quality concerns, they can be easily solvable in that scope that you have. The second one is around setting the right expectations with stakeholders. We've seen for some of our customers that they've thought that ML and AI is a magic wand that you can wave over your data and you can come along and get a huge amount of benefits, and that's just not a true fact. So, trying to make sure that you're clear and transparent with your stakeholders in terms of setting the right expectation is absolutely paramount. Otherwise, you're essentially setting yourself up for failure. And that comes up to the next one as well around, don't put all your eggs in one basket. Make sure that you've got a couple of machine learning projects that you want to come along and pilot. The reason being is that for various reasons, whether that be, legal, internal challenges, whatever it is, that machine learning use case may not be the right fit for the business, and it may not actually pay back the benefits that you're expecting. And hence why it's critical that you need to identify 2 or 3 machine learning use cases that need to be validated, tested, and obviously then you pick the best one to be productionized later on. And then the last one is make sure you engage the business from day one. Don't build it and hope that they'll come. We've seen too many times that that has happened, and people unfortunately haven't been able to get the buy-in. If you're an amazing salesman, it could be a great way to do it, but unfortunately we just haven't seen many organizations do the build and hope they'll come well. So I'm just conscious of time, so I'm not going to go through all of these one by one, but I think the main thing here is the fact that we've also got some other lessons learned from people in industry who have called out what are some of the challenges they've been faced with in terms of implementing machine learning and artificial intelligence projects. I think obviously a lot of them align well to what I spoke about before. But this comes back to people not understanding what is advanced analytics and the skill sets needed to effectively deliver it. It's around having a lack of translators who can engage the business and analytics to be able to speak both languages to help the business identify where the value is going to be created and how the technology works. But from an analytics point of view, speaking to them as to how it needs to be technically done, and hence they can actually then more easily bridge that gap. The seventh one around squandering time and money on enterprise-wide data cleaning. It can take years and years and years to come along and clean data sources, and it will cost a huge amount of money. We strongly recommend that organizations start thinking about how can they deliver value around specific use cases, and then essentially clean it up as you go. And what that means is that you can prove out the value as you go throughout that exercise, rather than trying to solve all the issues and then prove value later on. It's just not going to fly with a senior executive. And then I think the other one is around, neglecting to quantify the analytics bottom line impact. This comes back to the point I raised earlier in terms of people might, implement a machine learning model, but they don't effectively track what is the actual value generated by an individual initiative. And this part is critical so that you can go back to your senior executives at a later date and say, the amount of value created by this model was $1 million, $2 million, $3 million. And obviously that then means that you're going to be able to then justify as to why this type of program should continue. So what are the key takeaways from today's session? I essentially have 4 of them. The first is that substantial value can be created by machine learning or undertaking a machine learning initiative given the right conditions. And obviously those conditions align with the things that I discussed today. The second is that, most of the use cases are aligned in 2 specific functions: helping your business grow, but also then reducing costs. Based on the current, new climate that we live in, there's obviously going to be probably a heavier focus around cost improvements than there is around growth. But obviously, when you start speaking about identifying use cases, these are going to be the 2 areas that you'll see most of them in. The third is around having strong data and cloud foundations to be able to support your machine learning initiatives. And then also lastly, working from the business problem back to the technology. And this is essentially the fundamental way that you should be thinking about data and technology, or digital and technology anyway, right? It's not really different between a machine learning project to a digital project. So before I open up to Q&A, I'm just going to leave it, the session with one call to action, which is around, we were the Amazon Web Services forecast and personalized launch partner in APAC, first and only. And what that means is that organizations looking to understand their forecasting, their demand forecasting, time series forecasting problems, and how Amazon Web Services technology can come along and effectively help them solve those. We essentially have a proof of value that we can run where Amazon Web Services will contribute about $7,500 to that assessment. And that will essentially be a principal consultant coming along, understanding what you want to achieve, looking at then how Amazon Personalized and Forecast could essentially be run on top of your data, helping you with some benchmarks to be able to understand the uplift and the capability that these 2 services can help you with, but also some high-level training for your team. But the other one is that if you don't have forecasting and personalization use cases, for selected eligible customers, we can actually run a complimentary discovery workshop. And what we've found is that for organizations trying to understand the use cases and how to prioritize those use cases, this discovery workshop, is quite valuable for them. So in the coming days after this session, we'll reach out to you to let you know about this discovery workshop. So before I open it up, the last thing I want to leave you with is essentially a proverb. And this proverb is a person who asks a question is a fool for 5 minutes, but essentially the person who does not ask remains a fool forever. And the reason I say this is the fact that a lot of people feel that they've got a question that they might be embarrassed about, but I don't believe there's any embarrassing questions, and I'm more than happy to answer any of them. So please feel free to type your questions now in the chat, and I'll read them out and answer them for you. So please just make sure that you send them through into the all panelists and attendees, and I'll be able to see them. If there are no questions in the next 1 to 2 minutes, I'll wrap up the webinar. As I said, the plan is to send the recording in the next couple of days. So if you want to revisit any of the content, essentially we'll be sending you a link in the coming days. Looks like I've got a question, guys. Any use cases you can think of in the logistics industry? So when you start speaking about the logistics industry, there are quite a few use cases that you can think about. The first one typically that comes to mind is around routing optimization. That's obviously, it's a use case that can deliver a huge amount of value if done effectively. There is a type of mathematical optimization that is done to essentially solve that traveling salesman problem. So that's essentially one of the main use cases that I can think of. The other one is around predictive maintenance, or essentially around truck servicing. So obviously there's an optimal time to retain a truck, but also to start thinking about depreciating it. And that could be around thinking about, when is the engine going to start failing? What is the optimal service schedule to have on that individual vehicle to essentially make sure that it's running effectively and minimizing the cost to service that individual vehicle? The other one that we've done in the logistics industry is around demand forecasting. So we've done some work in a waste management business, and that waste management business wanted to understand what is the waste being generated by their customers in the next 1, 2, and 3 weeks. The reason being is that if they have an idea about the amount of waste that's being generated by their customers, they can obviously start thinking about optimizing how they service those customers. So that's another good one, is that if you can start thinking about doing demand forecasting for the services that you provide, that can be quite a good use of time. The other one is in terms of asset utilization. So obviously you have a certain number of trucks and you have a certain number of people, and if you have a forecasted amount of packages or goods that you're going to be delivering, you can then start planning what are the amount of vehicles that you need to have on the road, or essentially that you need to be purchasing, but also the number of drivers and hours that they need to be doing to deliver that effectively. We've also worked with quite a large supply chain organization in terms of distribution center optimization, and this is in terms of forecasting volume in, volume out, doing benchmarking of individuals in a distribution center to understand performance. And this is around understanding roster optimization, but also compliance with those rosters. So there's a whole bunch of things that you can do around the distribution centers as well. Lastly, someone's asked around, does AWS have an AutoML feature? And if so, how mature is it? The answer is yes. In Amazon SageMaker, there's something called Autopilot, which is their AutoML feature. In terms of how mature is it, it was essentially announced at their reInvent conference last December. So this is about 6 to 7 months ago now. What I would say is that most AutoML technologies in general are still quite new. And because they're quite new, you'll find that they don't do as well as a data scientist in terms of building custom models. But what you'll find is that if there's a business case that doesn't stack up for having a data scientist come along and build a custom model, one of the quick ways in which you can get a win out of it is by using these AutoML features. So this is why we see that Amazon Forecast is a great way to help customers build ML solutions. The reason being is that uses AutoML under the hood for time series forecasting, and essentially allows customers to select the best model. And what this means is that for those specific use cases, the cost to actually implement them is massively reduced. And that means that obviously business cases that were previously didn't meet the ROI conditions now start becoming a bit more palatable from the business's perspective. But what I would say is at the moment, I haven't done much hands-on work with the AutoML feature in SageMaker. My understanding is that it's built off some of the open source implementations, and because of that, it will be comparable to what the open source implementations are. So in terms of benchmarking AWS's AutoML versus others, it would essentially be at industry standard. But obviously I've seen custom machine learning models still outperform AutoML solutions at the moment. So if there's no more questions, guys, I'm going to wrap it up here because I'm 4 minutes over and I'm just trying to be respectful of everyone's time. So if there's no more questions in the next 10 seconds or so, I'm just going to do a bit of a wrap up. Great. So I'll leave it here. I want to thank you all for taking the time to attend today's session. It is really appreciated. If there's any questions that you do have that you didn't feel like answering today, please feel free to send me an email. I'll be following up with you in the next couple of days with a link to the content, so you can actually come along and download this and rewatch it if need be. But again, thank you for your time, and we look forward to seeing you at our next webinar.